Alright, if events A and B are disjoint, then A or B is equal to probability of A plus the probability of B. If events A and B are not disjoint, explain why this formula does not work. So, if they are not disjoint, that means that there is overlap, and so there's some part of it that would be counted twice. So, there's overlap that gets counted twice. Because it occurs in both A and B. So this scenario, there's this overlapping area in the middle that we have to get rid of. That's why the formula doesn't work. In general, whether events are disjoint or not, what is the formula for finding the probability of A or B? Do you remember what that is?
It's like P A/B.
Union B. Union. Union.
Union B equals P A. Oh yeah, P A minus P B. Right?
Plus.
It's plus.
Then what? What do I have to take off? So minus the probability of A intersect B.
I do not remember that.
But we definitely did. It's just been a little while. This is chapter 15. It's like the very first thing we did after break.
I don't remember
That one's coming up. Explain the difference between the addition rule for disjoint events and the general addition rule. You probably haven't really seen it written that way before, so I'll just say. The only difference is that for the general addition rule, that's why I'm just abbreviating it to GAR, is that it works for disjoint and non-disjoint because it subtracts off the overlap. So the addition rule is the equation that was written in question 1. The one that's the general addition rule is this one that we've written here in question 2. What is meant by joint probability? Kinda. The probability that two events are related. So not necessarily overlap, but kind of that concept. What is meant by conditional probability? And then the next question will be the actual formula for it. Mm-hmm. Yeah, so it's the probability that something happens given that something else has already happened. You remember what the formula is for it?
Yeah, so P is it A/B or AUB?
Slash.
Okay, so A/B equals P A intersect B over P parentheses B.
Yep. So this is the probability of A given B. Is the probability of A given B the same as the probability of B given A?
No. When you divide it by different numbers. So you get different answers.
Yeah, so it kind of depends on how you look at the question, because you're technically using the same formula and you can call either set A or set B. But if we assumed that we had decided that this is set A and this is set B, if you were to switch them, you are going to get a different answer. So we're going to assume that that you were given already what A and B was. So no, because it changes what it is being divided by. Now, I guess theoretically it could come out to be the same, but there's not a guarantee of that. Let's see. In general, whether events are independent or not, what is the formula for finding the probability of A and B? So the probability of A intersect B is equal to the probability of A times the probability of B given A. And obviously we could switch that and do the probability of B times the probability of A given B. And if you're just so curious to know where that comes from, probability of A times the formula for probability of B given A is probability of A intersect B over the probability of A. So those cancel and leave you with the intersection of the two. All right, explain the difference between the multiplication rule for independent events and the general multiplication rule. So, if A and B are independent, then the probability of A intersect B is equal to the probability of A times the probability of B. But that you have to know already that they're independent. If they're not independent, then the probability of A intersect B is equal to the probability of A times the probability of B given A. So much like the general addition rule that you can use for everything, the general multiplication rule, when they're not independent, also will always work. So even if they are independent, this formula still works. So in a lot of respects, it's easier just to memorize this general one and use it. All right, state the formula used to determine whether or not two events are independent. Do you remember what that formula was? Or like what we use to prove that that they're independent?
So it's like relative months.
Do you need me to tell you what it is? All right, so it's the probability of B given A is equal to the probability of B, or we can also write it as the probability of A given B is equal to the probability of A. So you just have to show that basically that the given condition is equal to whatever, because that shows that it doesn't change each other.
If I just lip sync. That's gonna work, right? That's gotta work.
I mean, probably.
I would stay boogies together.
I don't think anybody's really going to care that much. And if they do, it won't be till after the fact and it's over, so. So and if they do care, it won't be till after the fact when it's over, so what are they going to do then?
Yeah, I'm definitely lip syncing.
You just have to look excited about it.
I look excited. That's gonna be wrong.
All right. Chapter 16. What is meant by a random variable?
Variable with any given solution.
How about a value based on the outcome of a random event?
See, I don't like describing words, but like reading definition of words with the word in it. Cause like it just
See, but that would imply that I care about that. I'm a math person. I'm not Miss Patton.
I mean I know, but it's like it's whatever, I guess, but that's just how I interpret things.
Is what it is. It's math class. Explain the difference between a discrete random variable and a continuous random variable. For discrete, it's a variable we can list out all possible outcomes continuous is a variable that can take on or take any numeric value within range. What information does a probability model give? It gives all possible values and their probabilities of occurring. All right, what is the expected value of a random variable, or like what is another way that like you would interpret that? Expected value, another word for it.
Another word for expected.
Like expected value, yeah. It's like the expected value. When we find the expected value, what do we classify that as?
I've been out for too long. I forgot.
It's all right. The average or center of the model. So then how do you calculate the expected value of a random variable? We multiply each possible value by the probability that it occurs. Then find the sum so E of x, which is expected value, is equal to the sum of x times the probability of x. The difference between x and the little mu of x, x bar, or I guess this is supposed to have a little bar on it. X bar is the sample mean, and then mu sub x is the population mean or model mean. Also, this one is supposed to be mu of x is equal to 5, not the little thingy. So suppose mu of x is equal to 5 and mu of y is equal to 10 according to the rules for means. What is mu of x plus y? So that would be mu of x plus y is equal to mu of x plus mu of y, which is equal to 5 plus 10, and that would be 15.
Number 5, should it be like another parentheses next to that x, or is that
Right here,
yeah.
that's the summation symbol.
I'm talking about the end. Because I want to put 2 greater than
It's open.
Yeah, I thought it was like another parentheses.
No, it's just like that. We're gonna skip 8. It's not really important. 9 is missing a piece at the end as well. It's supposed to be sigma of x squared is equal to the summation of x sub I minus mu sub x, whoops. Hold on. Mu of x squared times p of I. So then how to calculate the variance, we subtract the mean from each value. So that's what's happening inside the parentheses. Square the new value, so that's what's going on in the parentheses being squared. Then multiply by its probability, which is the times the p sub I. And then take the sum of it. Um, 10, given the variance of a random variable, explain how to calculate the standard deviation. The standard deviation is the what of variance? No, it's a mathematical operation. So variance is equal to something of standard deviation. Square root. Variance is the square root of standard deviation. Wait, that's backwards. Hold, please. This. I need to put the square on it. Or you can say variance is equal to standard deviation squared. That's why I moved the quiz to Monday. We're not going to do the last two because you don't need to know them. All right. Highlighting what you need for quiz. On this one, you need 10, 6, 5, 3, and 1. So 1, 3, 5, 6, and 10. And then if we go back to the other page, you need 2, 4, 5, 6, 8, and 10. Not necessarily that the other stuff isn't important, but those are the ones that could specifically be asked to you on the thing. And I'll check your formulas for you for the quiz when you write them, if you want them checked.